We just now proved that the angle subtended at the center by an arc is double that of the angle subtended by the same arc on the circumference. That is, if we knew that this was 100 degrees, I'm just assuming it is not to scale. Suppose we are given that angle AOB is equal to 100 degrees, then we can say, using this theorem which we have proved in our earlier video, that angle APB is equal to 50 degrees, half of angle AOB. But we have done all this using the angle subtended by the minor arc AB. AB is the minor arc here. So what would happen if the angle is subtended by the major arc? It is the same case. Let us just see. So let me call this AB, or let me call it AQB. AQB, the major arc here. So we are just including one more letter because it's the major arc. Let me highlight the major arc. It's a little difficult because it's longer. So I'm just putting dotted lines. Yeah. So this is the major arc. Fine. And what is the angle subtended by this major arc? If this is the center O, let me join the endpoints of the arc to the center, AO and OB. So now we'll have to talk about this angle, the reflex angle. So in my earlier example, I had said that angle AOB was 100 degrees. So what would be the reflex AOB? It would be 360 minus 100. Reflex AOB would be equal to 260 degrees. This would be equal to 260 degrees, right? So what is the angle subtended by the same major arc on the circumference of the circle? So let me call this point P on the circumference. So yeah, I'm just connecting the point on the circumference to both the ends of the major arc. So now we'll have to talk about angle APB, and we would see that angle AOB would be equal to twice of angle APB. The proof is the same as before. You may just try out the proof and let me know if you need a video on it. I'll certainly do it. So this angle would be found to be 130 degrees if this was 260 degrees. But what I wanted to stress in this video was, what if the major and the minor arcs were equal? Meaning, what if we are considering the semicircle? Or what if the arc is this, the diameter AB, and the arc is exactly equal to the other arc? So what is the angle here subtended at the center by this diameter AB? It is 180 degrees because AB is a straight line. So the arc AB here, or this arc, exactly equal arc AB, subtends angle at the center equal to 180 degrees. Now let me just show you the angle subtended at any point on the circumference of the circle. So it is this. This angle is subtended by the same arc AB. And what would be the angle? It would be half of 180 degrees, isn't it? So APB, angle APB would be equal to 180 by 2, which is 90 degrees. And this is the proof for angle in a semicircle is always 90 degrees, right? So wherever this arc, this angle is, suppose I draw it this side and call it P1, AP1B would also be equal to 90 degrees. So this is the proof for angle in a semicircle is equal to 90 degrees. It follows from the inscribed angle theorem.